so it's a bit of a mouthful. So I'm representing Liam Lewis today, who's supposed to do the presentation. He's a manager of the centre and wasn't able to make it. So the presentation today will just give you an overview of our centre at the CIT, how we work with Enterprise Ireland and also with industry and some of the projects that we work with as well. So CAPA is one of 15 technology gateways set up by Enterprise Ireland back in 2003. It was set up between Enterprise Ireland and the Institutes of Technology with 23 million worth of funding. It had the remit to go out and link industry and give industry access to R&D so they could develop their products and give them a whole range of different specialities across the country that they could access. So Enterprise Ireland and through the ITs, the projects that the centres have actually worked on about nearly over 1,000 projects since 2013. We've also, in CAPA, we have about 2.5 million worth of projects ongoing as well. I'm sorry, I should have clicked on the... So we have about 2.5 million worth of projects ongoing in CAPA. It's a very competitive process to get a gateway through Enterprise Ireland. It's a 60-page application process, so not all the Institute of Technologies are on board at the moment. We're located in Cork and also in Tyndall. We have about 6 labs with, between the two centres, we have about 300 square feet of lab space. The building in CIT has just been opened last year, so it's state of the art. We're very happy to be working there from the previous building. It's a big jump up for us. I won't go through all the facts and figures here. So just key numbers. We've grown to about, that number is wrong, we're up to about 27 full-time researchers, 17 which are postgraduate researchers, so we have a large footprint. Just to give you a background of photonics, photonics is basically generation, controlling and detection of light. It is a huge range across almost all materials have a spectral response, so the applications are very wide. It can be very cheap or it can be very expensive. So the lab equipment that we use will be very expensive. We have high-end lasers, in the lab itself from 200,000, but down to €1,000 we could develop a little prototype device that can measure exactly what you want, say fluorescence, pH measurements, flow measurements, all sorts of different measurements, but we can miniaturize those devices to move them closer to the production line as well. As I said, it can be a small footprint. It's non-invasive, non-destructive, so light is very good for actually not interfering with your product. So it's great to have in the process, so you have no worries of any adulteration or anything. And it's a whole range of process, so across from food all the way to agriculture into biotech and pharmaceuticals. So just to give you a kind of an overview, really, as I said, Enterprise Ireland, we have a remit to give access to industry to research and development. We do have a lot of experience in accessing grants, so accessing grants and national and EU funding. So we're not only just a research centre, but we can help you, we can give you our experience as well and help you to apply for funding at EU level, which is very difficult to get, but we have a lot of success in that areas as well. So in our labs, we give you a lot of access to specialised equipment. So and we have a full range from SEM, which is a scanning electron microscope, that has EDX capability, which sounds very technical. But basically, we can get very high magnification on failures of any devices down to nanoscale. And we can also give you a spectra. So if you come into us with a contaminant, we can identify the contaminant, tell you what it is. And if you give us references, then we can compare and tell you, okay, it's possibly from the hood, or it's possibly from this, or wherever it came from. So that's very good as well. We have then access to a whole load of spectroscopic equipment, which from Raymond, NIR, UV-Vis, so we have a whole range. So we can look across the whole range of light, so we can look at any material from tableting all the way through to foods and cheeses and so forth. So just an example, I suppose, Prophotonics are an LED and laser illumination specialist in Cork. Now, this example probably is showing an industry that is involved in light, but we've dealt with people from a whole range, from the pizza industry across to the pharma industry. So this is only just an example of the process. So we're always open to consultation in the centre. So come and talk to us. I mean, we can provide you access to the other gateways if we can't resolve it, if it's not photonics. But this is free. It's a one-day consultation. Prophotonics came in. They spoke to us. We had a look at it. We said that yes, we could work with you. It was a coupling of a fibre optic cable using UV curing. I can't go into further detail of the application because it's sensitive to the company itself. But basically, as was said earlier, that led to a feasibility study which is part funded. That was €9,000, so this can be commercial or technical. On this side, this is technical. And then that led on to an innovation partnership, which again is the 80% funded by Enterprise Ireland. And this has led on to other projects that we're working with the company as well. So it's a very successful collaboration there with Prophotonics in Cork. Just to give you an example of what I said earlier, miniaturization. So this is basically an oxygen detector. So what you would have in packaging, you'd want to, in a meat package, for example, you might want to sense the amount of oxygen present remotely. So what we developed here was using phosphorescence. So oxygen quenches the phosphorescence, and we can measure it then with a laser system. But what we've developed here is just a small, very small footprint, very small handheld device capable of logging the oxygen concentration. This is an example. So what we've done is we're kind of miniaturizing everything, and what we do is basically all the LCD and the conversion tools and the ICs and the programming is all done, and it's repeatable, and it's very similar for different projects. So depending on the application, whether it be pH, we might have a look at fluorescence. As I said, oxygen will be phosphorescence, but we could change the photonic head then to suit what your needs are. Across, as I said earlier, milk and cheese, so food, the nutrient value now to companies of food, so such as protein, fat, caseins, and they're all readily detectable by NIR or Raymond spectroscopy. So we can, I'll give you an example on the next page now where with cheese, we had a manufacturer, a pizza company, a large pizza company, I wouldn't want to name them, had a problem with their cheeses, and they approached us because their cheese was burning if they got it too early in the maturity cycle or too late in the maturity cycle, but they had no way of measuring because they didn't trust the packaging that was coming in to say, okay, they had a window of about 3 or 4 weeks where the cheese was of very, very good maturity. So what we did for the company was we measured the spectra over a long period of time, and we built, from the spectra we were able to build up a model then, and using the model then we can predict the maturity of the cheese, which if there was any doubts about the quality of the cheese, they could bring a sample to us, we could tell them where it was in the maturity scale. There's going to be a presentation, basically done by a colleague of mine, Dr. Mike McAuliffe, on chemometrics. But basically everybody has problems with large amount, vast amount of data. So what chemometrics does, it reduces the number of variables that you're looking at, and it allows you to gather the information and show it in a very simple manner. So we use it a lot for comparing contaminants. So basically, what it will do is it will show you what's related to what in the data. So it will take a huge amount of data in, look at small changes, and you'll be able to then break the data, so compare samples easier across the range. So Mike will be giving a presentation in 11:05 in the seminar 1 on this, which will be interesting to go to. Another, I suppose, example here is collaboration between CAPA, Tyndall National Institute, and Lake Region. So basically, CAPA developed the optical part of this sensor. Tyndall did the integration, and Lake Region did the guide wire. But basically, this is just to measure blood flow. So basically, as the blood flow changes, the scattering of light changes, and then using the Doppler effect, we can calculate the blood flow. So this can be brought then into angioplasty, so you can get the blood flow at the tip of a fibre optic cable, which is smaller than the size of it here. And then we change this sensor as well. We can use fibre optic sensors. Once we put a dye on the top of them, we can then sense changes in pH or flow or whatever. So the applications are very wide across the spectrum here. So just a summary, as I said earlier, photonics it's not a very narrow subject. It's a whole range from pharmaceuticals across the full. And basically, I suppose the key is to come and talk to us, have a look at what we can do, because a lot of companies and people don't underestimate the value of using light and how it can be applicable to their company. So thank you for your time, and if you have any questions, I'll
Great, thanks very much.
thank you.
Any questions from the floor?